All right, today we're going to dig into a metal that is, quietly shaping our entire future. I mean, it's not glamorous, but it's absolutely essential for pretty much everything. Electrification, AI, you name it. And this isn't just a story about some boring commodity. It's really about the physical backbone of the 21st century. Okay, let's just dive right in.
So let me just start with a question for you. When you think about the biggest technological shifts happening right now, what is the one physical thing, the one material they all have in common?
I mean, you've got this massive global switchover to electric vehicles. And then there's the huge build out of renewable energy, right? We're talking millions of wind turbines and solar panels all over the world. And get this, even the explosion in artificial intelligence, which relies on this massive network of enormous, power-hungry data centers.
Well, the answer connecting all of them? It's copper. It's the ultimate conductor. It's the silent hero, really, the enabler of every single one of these megatrends.
So what all of this is telling us is that we're entering a brand new age for this ancient metal. And to really understand where we're headed, and listen, why this is such a huge story for investors, we first have to get our heads around the sheer scale of this new wave of demand. Okay, now have a look at this. What's so interesting here is that this is where we are today. Construction, wiring in buildings, plumbing, that's still the biggest piece of the pie. But those slices for transportation and electronics, they are about to get a whole lot bigger and fast. In this slide right here, this just perfectly illustrates why. I mean, look at this comparison. A normal gas-powered car, it uses maybe 20 to 30 kilograms of copper. An EV, it needs up to 100 kilograms. That's almost 4 times as much. So this isn't just some small upgrade, it's a complete hardware overhaul for our entire transportation system. So what happens when you add up all the EVs, all the new wind farms, the new grid infrastructure, and all those AI data centers? You get to this number, a projected demand of 42 million tons a year by 2040. That is a staggering 50% jump from where we are right now. Just think about that for a second.
Okay, so demand is absolutely soaring. The logical question then is, well, why don't we just mine more of it? Well, it turns out the planet's geology and, frankly, our own regulations are creating a massive structural problem on the supply side. It's not that simple.
To really get this, we just need to know one key term, ore grade. And it's super simple. It's just the percentage of actual copper you can get from a chunk of rock you pull out of the ground. That's it.
So here's the crucial point. The quality of copper ore has been collapsing for decades. Back in 1990, the average ore grade was around 1.5%. Today, it's barely over 0.5%. Now think about what that means. For every single kilogram of copper we produce, we now have to mine and process almost 3 times more rock than we did just 30 years ago. And of course, that has some very real-world consequences. It means we need way more energy, a 25% increase in just the last 10 years. It means way more waste rock, a bigger environmental footprint, and at the end of the day, it just means it is much, much more expensive to get that copper out of the ground. But you know what? The biggest problem here might just be time. Let's imagine you discovered the world's greatest copper deposit tomorrow. Between all the studies, getting the permits, which can take a decade on its own, and then construction, it takes an average of 17 years before that mine produces a single ounce of copper. The supply side simply can't react quickly.
So now, let's put the two sides of the story together. The crazy high demand and the really constrained supply. This is where the math gets, well, really compelling. First, let's just remember that demand number. By 2040, the world is going to need around 42 million tons of copper every single year to power this whole energy transition. Okay, now for the supply side. Even if we're optimistic about new mines coming online, and we assume a big increase in recycling, the total projected supply is only about 32 million tons. And that leaves us with this, a projected annual deficit of 10 million tons. Let me try to put that in perspective for you. That's a shortfall equal to nearly 25% of total global demand. Wow. This isn't just a minor imbalance. It's a massive structural chasm opening up between what we need and what we can actually produce. So, what happens in a market when demand for a critical, non-substitutable resource is set to massively outstrip supply? Well, Economics 101 tells us that something's got to give, and that something is price. And hey, you don't have to take my word for it. Just look at what the major analysts are forecasting. JP Morgan, they see a structural floor around $12,000 a ton.
Citi's bull case goes even higher. And Wood Mackenzie, they highlight what they call the incentive price. That's the price needed to make it profitable to even build these new, difficult mines. And that's at over 11,000. The consensus is crystal clear. Prices have to go higher, maybe a lot higher, to balance this market.
So what's the takeaway here for anyone watching the markets? It's this. Copper is shifting. It's not just a cyclical play on global growth anymore. It's becoming a strategic asset tied to the long-term trends of electrification and AI. The physical reality of geology and time, these are now powerful economic forces. And what that suggests is that, for this huge deficit to ever close, prices will likely have to stay elevated for a very, very long time.
You know, this whole situation brings us to a much bigger idea. As the Capital Market Journal puts it, our technological ambitions are, at their very core, limited by physical reality. We can dream up and design these incredible new technologies, but at the end of the day, they still have to be built out of materials we pull from the earth.
Which leaves us with this one big final question. We are betting our entire clean energy future on all of these technologies that all depend on this one single metal. And the data clearly shows we are just not on track to have enough of it. So, will we find a way to make copper the great enabler of our future, or is it going to become the ultimate bottleneck that slows everything down?